Okay, so going over the first day of homework, they're talking about long run probabilities and false positives and negatives. In the first one, I'm actually going to share my screen so that way you guys can see the assignment as well. Here, I'll drag this out. Okay, so in this one, it says liar, liar. Sometimes police use a lie detector, also known as a polygraph, to help determine whether a suspect is telling the truth. A lie detector test isn't foolproof. Sometimes it suggests that the person is lying when he or she is actually telling the truth. This is known as a false positive. Other times a test says that this suspect is being truthful when really they're lying. That's a false negative. For one brand of polygraph machine, the probability of a false positive is 0.08. In A, it says to interpret this probability as a long run relative frequency. If you watch the video when I talked about this lesson, long run probability is the only reliable. Again, probability is chance outcome. So in that case, anything can happen in the short run, but in the long run, it has a predictable pattern. So in this one, when I'm talking about a long run probability, is that the polygraph will deliver a false positive about 8% of the time, or 8 out of 100 responses. Okay, so in the long run, that's what happens. It does not mean that, oh, I've had 7 out of 100, or 7 out of 99, so the next one has to be a false positive. It's in the long run, you have that probability. In B, it says which is more serious, a false positive or a false negative. In this case, a false positive would actually be more serious. A false positive means that the lie detector went off and said that someone was lying when really they were not. That would be the more serious because it would show that someone lied when really they didn't lie. Okay, the next one is talking about mammograms. Many women choose to have an annual mammogram to screen for breast cancer after age 40. A mammogram isn't foolproof. Sometimes the test suggests that a woman has a breast cancer when she really doesn't. That's known as a false positive. Other times it will deliver a false negative. Suppose that the false negative rate for a mammogram is 0.10. It's much lower than this in real life. But what that means is that in the long run, the mammogram will deliver a false negative in 10 out of 100 tests, or 10% of the time. That's what that 0.10 means. Okay, so in this one, it says which one is more serious. It's definitely a false negative that would be more serious, and here's why. A false positive would mean that they would say, yes, you have breast cancer, but really you do not have it. That would be such a bummer. Such a bummer for a couple days until they figured out that, oh, you know what, you're okay, you actually don't have it. A false negative, on the other hand, in the medical world for this one would be really awful. The subject would think that they did not have cancer, but really they did. As we all know, cancer untreated can be very serious. So false negatives would be a very unfortunate circumstance when you're talking about cancer. Okay, in number 3, you have a probability where it says, suppose a married man and woman both carry a gene for cystic fibrosis, but don't have the disease themselves. According to the law of genetics, the probability that their first child will have cystic fibrosis is 0.25. What that means is 25% of the time their child could be born with cystic fibrosis. Explain what this means. So 25% of the time their child would have cystic fibrosis. The idea of that is like a 1 in 4 chance of having cystic fibrosis. It says if a couple has 4 children, is one of them guaranteed to have cystic fibrosis? This is the idea of the law of large numbers versus small numbers. If you're having a small number of children, 4 children, it's very possible that none of them have cystic fibrosis. So the answer is no. Probabilities are estimates of true events, chance outcomes, but in this case, you're not going to be guaranteed 1 in 4 children will have cystic fibrosis. In this case, again, that's the law of small numbers. If this couple were to have 4,000 children, then it's likely that about 25% of their children would have cystic fibrosis. But in this case, if you're only going to have 4, anything can happen in the short run. Okay. Next one talks about Texas Hold'em. So in this one, it talks about an 88 and 1,000 chance of having 4 of a kind. And so it says, explain what this probability means. It means that if you were to play 1,000 hands of poker, you would expect to have 4 of a kind in approximately 88 hands. And it says, okay, so will that happen exactly in that? We all know the answer to that is no. This is an approximate estimate of chance outcomes. Okay, it's an approximation. It's not that you're guaranteed that. Okay, and your last one, talking about spinning a quarter with your forefinger, hold a new quarter, upright on its edge on a hard surface, then flick it with your forefinger so that it spins before falling. Okay, you're doing this 25 times and you're recording the results. What is your estimate for the probability of a heads? Well, the probability is going to be a 1 in 2 chance or a 50% chance. The probability is actually written this way, 0.5. I often make it a percentage just so that I can interpret it better for me. So 0.5 probability is a 50% chance. There are 2 equal sides. There are 2 sides with equal chance. Explain how you could get an even better estimate. The best estimates are always simulated by simulating many trials. Instead of just 25, bump that up to 100 times or 1,000 times, and then you're gonna get a better estimate. That was that graph that we saw where it was like in the short run, you saw this big variability, but then as you started to do more and more trials, it got very close. It wavered very, very close to that true probability. And that is all for homework help.